Imagine a universe not simply empty, a void devoid of anything at all, but instead picture it filled with an invisible, all-pervading substance, something that permeates every corner of existence. We call it the ether. For centuries, some of the greatest scientific minds believed this ether was the very fabric of space itself, a necessary medium for the propagation of light and the transmission of gravity, much like air serves as the medium that carries sound waves to our ears. Thomas Jefferson Jackson C., an astronomer working in the early 20th century, a time of great scientific ferment, took this already expansive idea even further, pushing its boundaries to new limits. C. boldly proposed that ether was not just a passive medium, but the very source of all matter and energy, a fundamental cosmic ocean from which everything we observe in the universe ultimately emerged. The appeal of this idea? Ether offered a seemingly simple mechanical explanation, a clockwork universe in action, for how forces like gravity could act instantaneously across the vast emptiness of space. It made the universe feel tangible, interconnected in a fundamental way, and therefore more easily understandable to the human mind. But the nature of science is to constantly evolve and challenge existing ideas. The famous Michelson-Morley experiment conducted in 1887 ultimately failed to detect the presence of ether, despite the researchers' best efforts. This negative result dealt a major blow to the ether theory, casting serious doubt on its validity. Then, Einstein's groundbreaking special relativity theory in 1905 elegantly showed that light, in fact, didn't require any medium whatsoever to propagate through space. Its speed remained constant for all observers, regardless of their motion. The classical concept of ether gradually faded from the scientific landscape, but the fundamental human desire to find a unifying fabric of reality, a deeper level of understanding, continued unabated. Scientists began to explore new, more abstract and sophisticated ways to explain the universe's seemingly hidden connections and underlying order. The core idea of an underlying unity, something fundamental that binds everything together in the cosmos, remained an irresistible draw for researchers. C's particular vision was eventually replaced by entirely new paradigms and theoretical frameworks, but the underlying longing for a cosmic medium, in some form, never truly disappeared from scientific inquiry. Today, in the 21st century, we still search diligently for the most fundamental substance or underlying principle that governs and connects all things in the universe. The story of ether, therefore, is ultimately a story of human curiosity, the power of imagination, and the relentless human drive to deeply understand what truly connects all the diverse elements of the cosmos. And as we'll soon discover, the quest for this elusive unity continues to this day, taking on exciting new forms and expressions in both the realms of theoretical physics and pure mathematics. Now, let's shift our focus from the tangible, physical world to the realm of the abstract. We're going to delve into a concept that might seem a bit removed from everyday experience at first. It's called the Axiom of Choice, sometimes referred to as the Aether theory. This is a cornerstone of modern mathematics, a principle that allows us to make certain kinds of arguments and proofs. This principle, in its simplest form, states that you can always pick one item from each box in a collection. Imagine a series of containers, each holding different objects. The axiom of choice asserts that it's possible to select one item from each container, even if there are infinitely many boxes stretching out before you. Now, importantly, it doesn't tell you to choose. It doesn't provide an algorithm or a specific method. It simply guarantees that a choice possible, that such a selection can be made. To illustrate, imagine an infinite pile of socks all mixed together. If you have pairs of socks, the axiom says you can select one from each pair, creating a new collection. This holds true no matter how many pairs there are, even if the number of pairs extends to infinity. Either this or that selection, this fundamental act of choosing, is a cornerstone, a fundamental building block in the edifice of mathematics. The axiom of choice allows mathematicians to prove the existence of mathematical objects, often without needing to provide a step-by-step method for constructing them. It's a controversial idea because it asserts existence without providing a concrete method. It's like saying there's a path through a dense forest, but not providing a map or any directions to find it. Still, despite the controversy, it's absolutely essential. Many fundamental theorems in mathematical analysis, in topology, the study of shapes and their properties, and in abstract algebra, all critically depend on the axiom of choice. Without it, entire branches of mathematics would look radically different, perhaps unrecognizable. The axiom of choice is an incredibly powerful tool, opening up vast conceptual possibilities and allowing us to explore new mathematical landscapes. Ultimately, it's a statement about the fundamental nature of what's possible within the mathematical universe. And as we'll soon discover, this seemingly abstract idea of selection, of making choices, may have surprising and profound echoes, even tangible consequences, in the physical world around us. The power to choose, even in the abstract realm of mathematics, profoundly shapes the very foundations of logic, reasoning, and our understanding of reality itself. The Aether principle, therefore, is far more than just a mathematical curiosity or a technical detail. It's a key, a fundamental insight into understanding how possibilities, in the abstract, ultimately become actualized in the world. Now, let's explore recursion, a concept that might seem a bit abstract at first, but is surprisingly intuitive once you grasp its essence. It's a process where something is defined in terms of itself. This might sound circular, but it's a powerful tool in mathematics and computer science. Think of Russian dolls, those charming wooden figures, each containing a smaller, nearly identical version of itself nestled inside. This is a perfect visual analogy for recursion, or consider a fern leaf with its intricate structure, where each frond in its shape and form mirrors the whole, exhibiting a self-similar pattern. Recursion isn't just a mathematical curiosity, it is everywhere. Look at the fractal coastline of Britain, with its jagged edges repeating at different scales. Observe the branching of trees as they reach for the sky, or marvel at the intricate patterns of snowflakes, each a unique masterpiece. In computing, recursion lets a function solve complex problems, often with elegant and concise code, by breaking them down into smaller, identical subproblems until a simple base case is reached. Simple recursive rules, when applied repeatedly, can generate immense complexity and beauty, as seen in fractals. Think about DNA replication, or the formation of galaxies, and even weather patterns like hurricanes all show recursive behavior, exhibiting self-similarity at different scales. Recursion suggests the universe's richness and diversity may arise from simple rules, endlessly repeated, creating intricate and fascinating structures. It's a fundamental organizing principle, a blueprint for creation, connecting the very small, like atoms, to the very large, like galaxies. Recursion builds complexity from simplicity, demonstrating how a few basic rules can lead to astonishing results, hinting at a universe that creates itself through repetition, constantly evolving and refining its structures. We see it in nature, in the spirals of seashells and the branching of rivers, and in technology, in the design of computer chips and algorithms, and even in the way our minds process information, forming connections and recognizing patterns. Recursion is a thread weaving together seemingly disparate elements, the living and non-living, the simple and the complex, revealing underlying connections. It's a key to understanding how the universe builds itself, from the smallest particles to the largest structures, one step at a time, in an iterative dance of creation. What if the universe is built from recursive processes generating harmonic patterns? The recursive harmonic paradigm proposes just that. Reality emerges from repetition and resonance. Recursion is the engine, harmonics are the stable patterns, like a guitar string vibrating with overtones. Mathematical tools like quaternions and prime numbers help describe these structures. Primes are the building blocks, assembled recursively into complex forms. This paradigm is a modern evolution of the old Aether quest, but now the medium is abstract and mathematical. The universe becomes an active, self-organizing process, not a passive substance. It's a cosmos that sings itself into existence through cycles of creation. The recursive harmonic paradigm unites physics and mathematics, and perhaps even consciousness in a single, resonant framework. Mathematics is often called the language of the universe, and the recursive harmonic paradigm takes this seriously. Prime numbers, indivisible, fundamental, are seen as the atoms of the numerical world. Every whole number is built from primes, making them candidates for the building blocks of reality. Patterns of primes might correspond to properties of particles or quantum states. The structure of numbers could be the blueprint for the structure of the physical world. Geometry matters too. The torus, a donut shape, is a key symbol, cyclical, self-referential, and continuous. The torus represents systems where energy or information flows endlessly, embodying recursion and feedback. This approach unifies abstract math and concrete reality. The universe doesn't just obey math, it is math. Numbers and shapes aren't just descriptions, they are the architecture of existence. Prime numbers and the torus become the patterns from which everything unfolds. The recursive harmonic paradigm suggests reality is built from mathematical relationships, not just physical stuff. The universe's blueprints are written in the language of numbers and geometry. Let's weave together ether and either, the medium and the power of choice, within this recursive vision. The old ether was a physical substance, but today's physics sees a dynamic field of potential, like quantum fields. The axiom of choice resonates here. From infinite possibilities, reality selects a specific outcome. Recursion provides the mechanism. Each step narrows possibilities, creating stable patterns. The harmonics that emerge are the persistent choices, the fabric of reality woven from potential. Reality isn't static, it's a process, an interplay between potential and actualization. The universe is constantly making itself, choosing its path from infinite options. The laws of physics may be the rules guiding these recursive selections, shaping the ongoing creation of reality. The torus, a donut shape, serves as a powerful metaphor for the universe's recursive, interconnected nature. It's finite yet endless, embodying cycles, feedback, and harmony. In this paradigm, the torus underlies everything from particles to consciousness. Energy and information flow through its loops, creating complexity and self-sustaining systems. We, as observers, are not outsiders. We're woven into this toroidal flow. Our consciousness and choices are part of the fabric of reality. Observing a quantum system changes its state. Mind and matter are deeply intertwined. Reality is co-created by the universe's recursive processes and our participation. We are both in the universe and of it, active participants in its unfolding story. These grand ideas aren't just abstract, they echo in the world around us. Recursion appears in seashells, galaxies, and the branching of trees. The act of choice is fundamental. Every decision we make actualizes one possibility from many. The recursive harmonic paradigm reveals how the small reflects the large, and the simple informs the complex. The same math that shapes a sunflower's seeds may govern space-time and consciousness. The universe is an integrated whole, a symphony of recurring themes and harmonious interactions. This interconnectedness touches biology, neuroscience, and philosophy. Patterns in nature are clues to the underlying mathematical order. The rules of recursion and choice shape everything, from the inanimate to the thinking. The universe's patterns are whispers from the deep order that connects all things. From ether to either to the recursive harmonic paradigm, we glimpse humanity's quest to understand the universe. Imagine a cosmos where everything is linked by recursive principles and harmonious resonances. The paradigm is a work in progress, a lens for interpreting knowledge and guiding discovery. Many questions remain. How do primes encode reality? How does consciousness fit in? Science is about embracing mystery, asking big questions and seeking deeper answers. These ideas are starting points, inviting us to see patterns and connections everywhere. The universe is an unfolding story, and we are privileged to be part of it. The quest to understand is one of our greatest adventures. The universe is whispering its secrets if we learn to listen.